This is the second video. Now I'm going to show you two examples in two videos, video number 2 and video number 3. For each example, I'm going to show you about two different methods to do each problems. So now it's more like intermediate level. So example 3, we want to verify identities. The equation we have is tangent squared t over secant squared t. On the right hand side equal to 1 plus cosine of t times 1 minus cosine of t. So with all the same rules, we have the left hand side, we have the right hand side. For this one, we're going to start from the complex side. We always start from the side which is more complex because that will give us more room to simplify it. For this one, even though the right hand side looks much longer, yes, we can multiply them, but because we have cosines mainly, we cannot really modify cosine. On the left hand side, we have tangent and secant. Even though the whole expression looks smaller, looks shorter, but tangent can be rewritten as sine over cosine. And then secant can be rewritten as 1 over cosine. So comparing to the right hand side, we have more space, we have more abilities to rewriting the left hand side. So that's why the left hand side is more complex. So from this one, you can say comparing to just the 6 trig values, sine and cosine are the simplest one. So we don't really choose sine and cosine over tangent and cotangent. We normally choose tangent, cotangent, secant, cosecant to start first because we have more room to changing around. Okay, so I'm going to show you two different methods. The first one, so I probably need to rewrite the problems again. So I have tangent squared t over secant squared t, 1 plus cosine of t, 1 minus cosine of t. So the first method is I'm going to work as usual. I'm going to start from the complex side, which is the left hand side. We just talk about it. Because I have a fraction, yes, I can continue working with the fraction form, but I prefer, because I'm going to rewriting tangent and secant into its own fraction version, so I prefer to rewrite the division bars to a division sign. So left side will equal to the right tangent squared theta divided by secant squared t, where tangent squared t can rewrite it as sine squared t over cosine squared t. Secant squared t can rewrite as 1 over cosine squared t. Dividing a fraction is the same as multiplying the reciprocals. Now I see cosine squared t. 1 is on the numerator, 1 is on the denominator, so I can simplify it into sine squared t. Okay, so this is probably the most simplest form I can simplify it. However, it's not quite equal to my right hand side. It's a little bit more not straightforward to continue from this point because I only have one term. So the first method is I'm going to stop here. And then I'm going to work on the right hand. I didn't erase anything for my first part, so everything is part of the method 1. So my right hand side, I'm going to multiplying it. I will end up with 1 minus cosine squared t. Even though I'm multiplying, it's not really giving me any sine from 1 minus cosine squared t. However, this one looks very familiar because we do have one identity says sine squared theta plus cosine squared theta equals to 1. So that means 1 minus cosine squared theta is going to equal to tangent squared theta. So for these situations, even though my left hand side, when I just simplifying left hand side, I didn't go all the way down to the right hand side. But since when I'm working on the left hand side and working on the right hand side, both will end up with sine squared t. So pretty much what I'm doing is I'm working from the left hand side to try to go to the right hand side, but it's not quite well. So I'm going from right hand side, try to simplify it to go to the left hand side, and then hopefully they're going to meet in the midpoint. For this case, the midpoint is sine squared t. So that means I can conclude from both parts, I can conclude that left hand side do equal to the right hand side, and I prove my identity. Okay, so that's the first method. But sometimes you feel it's a little bit too complicated. How do I know when I should stop? How can I I do want to continue? You can continue. So this is my method 2. Or if you are going to continue, I'm just going to really quickly copying down okay, so I'm just copying down the method 1 on the left hand side, and once I have the left hand side and then end up with sine squared t, you can continue. It will require you to know those formula or those identities very, very well. So we are going to using the same. We're going to use. We're going to use the same identities. So we're going to use the same one. Sine squared theta plus cosine squared theta equals to 1. So the sine squared theta will equal to 1 minus cosine squared theta. So sine squared t will be equal to 1 minus cosine squared t. And 1 minus cosine squared t, I'm going to factor it into 1 minus cosine t times 1 plus cosine of t, which equals to the right hand side.